Okay, so I did a little research, a little more studying on how to rotate a figure 90 degrees counterclockwise about a given point. It's not a particularly difficult thing to do, but as we figured out last night, there's not a lot of real good instruction on it, and I think there must have been a piece of the puzzle that maybe you didn't have in your notes. So I'm going to go over kind of what I found out and what I've kind of synthesized into the next few pictures. So we'll start with just a regular Cartesian plane, and we'll put the figure on it that we were working with last night after we had translated it over 4 and up 4. So we'll just use this for kind of our base, what we're going to talk about. So I've got a triangle ABC with the vertices just like they were last night, 3, 6, 1, 8, and 2, 9. So rotating at 90 degrees counterclockwise about the origin is one thing, and rotating at 90 degrees counterclockwise about any given point is a similar thing, but there's an extra step that we need to do to make that work correctly. So we know that if we rotate at 90 degrees counterclockwise about the origin, that we do this. That we take the x and the y, we flip them, and we change the sign of the y so that we have something like negative yx. And that rotates a point 90 degrees counterclockwise about the origin. Well, clearly we can't do that same thing and call it rotating about a different point besides the origin, because that would just rotate it about the origin. So how do we rotate 90 degrees counterclockwise about some other point that's not the origin? And in our case, we're going to try to rotate 90 degrees counterclockwise about point A, just like we did yesterday, and use point A for our point of rotation. So the first thing that we need to do to make this work correctly is imagine moving the origin where the x and y axis cross. Imagine moving the origin to the point of rotation. So imagine if the origin actually went through point A instead of the point 0, 0. And so point A will become our point 0, 0 on this imagined plane. So this is going to be kind of our new plane that we're going to imagine. We don't have to draw it that way necessarily, but we're going to imagine that that's it. Okay, so I'm going to represent that by this kind of faint orange line. So that's our imagined origin at point A. So after we imagine what that's going to be, what that looks like in our heads, or sketch it out on the paper even, we need to identify the points to be rotated in terms of new plane coordinates. So, like I said, our A has become 0, 0 in our new plane, right? So what are B and C if this is our new plane? Well, point B, if this is 0, 0, point B would be at negative 1, negative 2, so negative 2, 1, 2, and 2. So B would be at negative 2, 2. A would be at 0, 0, because that's what we're rotating around. That's where our origin is. And then C would be what? Can you guess? That's right, negative 1, 1, 2, 3. So it would be negative 1, 3. Now the reason it's important to figure out those coordinates is that we're going to then go back and apply this and flip them, change the sign of the y. And then we'll understand from point A where we need to move to get the rotation for A prime, B prime. Well, not, well, A prime will be where it is, B prime and C prime will be the ones that move. So we're going to use that xy, take that and change it into negative yx with the new plane coordinates to plot the rotated points. So our 0, 0, of course, is going to stay 0, 0. But what would our b become? So it looks like we would change that to -2, -2, doesn't it? Because we'd put it in terms of negative yx. So negative yx. So over 2 this way and down 2 would put our point b prime at -2, -2 on our imaginary plane. Or, see? So that would be our b prime. And then if we did c the same way, we would have -3, -1. So that would move us 1, 2, 3 to the left and down 1. So in our imaginary plane, -3, -1 would be our c prime. And that would look something like this. So we plot those, and that is what we get. Now, we just need to probably name those points by their correct names, which would not be in the imaginary plane, but we'd still have this as 3, 6, and we would have, or sorry, this being point A, or A prime would be still the same as A, 3, 6. B would be 1, 1, 2, 3, 4, 1, 4, and then C would be 0, 1, 2, 3, 4, 5. So 0, 5 for C. So these would be the points. And I think that these are the points that we came up with last night. I just didn't do a very good job of explaining, I think, how I was getting there. What I'm showing you today is maybe a better way to think about, or a system applying basically these things to get to that point. So the fourth thing again is to just identify the points in the original plane, call them by their real names, not by their imaginary names. So 3, 6, 1, 4, and 0, 5. Okay? So hopefully that makes it make a little bit more sense, or hopefully it gives you something that you can do to actually repeat that if you need to when you're rotating about a specific point. Now, our point was the same point or a point that was already in the figure. What happens when it's not a point that's already in the figure? Well, I drew out a couple other things for us to look at here. So I just created this triangle, QRS, with vertices at 4, 8, 9, 10, and 9, 4. And then I created another point down here called P at 3, 3. So I said, okay, let's apply what we just talked about and rotate this 90 degrees about the origin and see what that looks like, and then rotate it 90 degrees about point P and see what that looks like. So about the origin, I just took the coordinates, flipped them, and changed the sign of y, so negative yx in each one of these cases here. So Q prime in this case, about the origin becomes negative 8, 4, R prime becomes negative 10, 9, and S prime becomes negative 4, 9, and that's what this would look like in the green figure here. Well, there's the S prime. So that, the green figure here, is rotated 90 degrees around the origin. Now you can see how that kind of works. Like if you draw a line from R to the origin and then draw from origin to R over here, it is in fact 90 degrees. That's a pretty good sanity check, actually. If you take one of these and draw to the point of rotation and then draw to its corresponding point in the rotated figure, yep, it should be 90 degrees. Another thing you can do to kind of test that is you can take a sticky note or a piece of notebook paper or something, put one edge down at the origin, and then rotate it so that it lines up with between the origin and one of your points. So that's lining up kind of close to the origin and my R over here in the original figure. And then notice it, sure enough, it pretty much lines up over this way too. So I don't have it exactly centered up both ways, but that's my 90 degrees. So you could do that with your vertexes after you rotate them to see where they ought to be, and to kind of get an idea of whether you're in the right ballpark or not. Obviously, that's if we do that, we're going to see that we should 90 degrees is going to be over here in quadrant 3. It's not going to send us somewhere down here in quadrant. In quadrant 2, not down here in quadrant 3 or down here in quadrant 4. Now, what does it look like if we rotate around point P instead? Well, going through the process that we just went through, where I imagine now that my imaginary plane is right here going through my point of rotation, which now is 3, 3. So 3, 3 becomes my new imaginary point of origin. So to get to point Q from there, where do I go? Well, I go up, I go over 1 and then up 1, 2, 3, 4, 5. So it would be at my imaginary point, or my tentative point, 1, 5, right? So its Q prime over there would be negative 5, 1. So that means I would draw over 5, 1, 2, 3, 4, 5, and up 1. And that would be my actual Q prime. And then I would do the same for S and R. And end up drawing them here and here. And so this red triangle is the rotated version 90 degrees counterclockwise around point P. So it's a little tighter because the original figure is closer to P than it is to the origin. So the arc is a little bit bigger, I guess, when you rotate it around this way versus when you rotate it around P. So hopefully that will help. And if you have any questions, feel free to text, call, or something. We'll address them. So good luck, and see you next Monday, if not before. Bye.